welcome to GMaths Academy. I'm Victor. Today, we'll be treating standard form. We'll go through its definition, we'll show you how it should look like, treat examples, and at the end, we'll go over what we did. So, what does standard form mean? In case you don't know, standard form is just another way of expressing numbers that are simply too large or too small to be conveniently written in decimal form. They may also be called standard index forms or scientific form. So let's move on to its description. So a standard form expression should look this way: a multiplied by 10 raised to the power of n, where a is termed as the significand, ten the base, and n the exponent. As you can see here, n is an integer, 10 is just a whole number, a is any non-zero real number, right? Real number, meaning should be a number greater than or equal to 1 and less than 10. So let's look at how we can convert large or small numbers to standard form. So here we have 43 million. 1, 2, 3. Now, to remind you, there's always an invisible decimal point at the end of every number. To convert this into standard form, this decimal point is moved down to the first non-zero digit, which is 4 here. So we then have 4.3 multiplied by 10 raised to the power of, we have 1, 2, 3, 4, 5, 6, 7 raised to the power of positive 7. Positive 7. Now it is positive because decimal points move towards the left hand side. Our exponent becomes negative when the decimal point moves towards the right. Now, as you can see, our integer is 7 simply because of the number of digits in between the former point of the decimal point and the new point of this decimal point. So here's our answer. Let's move on to the second type of number. So here we have a very small number, 0.000000672. Convert this to standard form. So let's rewrite the number. We have 0.000000672. Remember to convert this again. We send our decimal point to the front of our first non-zero digit, which is 6 here, and this gives us 6.72 multiplied by 10 raised to the power of our integer, which will be 1, 2, 3, 4, 5, 6, and 7. This time we count the first non-zero digit. Take note of that. So we have raised to the power of 7 again. This time it becomes negative 7 because, as we said before, decimal point moves towards the right. When it moves towards the right, our exponent is negative. When it moves towards the left, our integer is positive. Let's move on to the next example. So here we are to convert back to decimal form or normal form. We have 5.268 multiplied by 10 raised to the power of minus 2. So notice our integer is negative. This means our decimal point has crossed 5 and another number. we fill this place up with 0. Put our decimal point, add another 0. So back to decimal form, we now have 0.05268. Now remember to always add the first non-zero digit in your counting. Now to our further explanation. So just as I've said, when the decimal point moves towards the right, the exponent is negative. And when it moves to the left, the exponent is positive. So that's just a point to note. So our hint is working carefully and step by step in line with the rules gives you an upper hand in converting any number at all encountered to standard form. So that's self-explanatory. So today I've introduced you to standard form. I'm sure you can convert any number to standard form. You know how standard forms look like. I gave you a hint. Thank you for watching this video. It's an overview. I see you next time.